right, well, thank you for joining us today for this automated CAM webinar. My name is Joy, and I'm part of the Nextgen Cam team, and I'm going to pass it over to Eric Strassheim, who is our COO, to kick things off.
Thanks, Joy. Hey, we're really excited to put on this show for you today and go over some of the ways that we have customers that are automating their CAM, improving their programming times, and just improving their companies overall. I've got Andy Barney, who has joined me here, and he has a wealth of experience both running the machines, running multiple softwares, and he's a senior CAM specialist on our team. We're very glad to have him today. He's going to run through some parts and show you practical examples.
Yeah, welcome everybody. Looking forward to showing you FeatureCAM and all of its capabilities. Thanks for joining us.
All right, just a heads up, who is Nextgen Cam? Who is Autodesk? Autodesk is the largest design software company in the world. And you can see they have quite a few customers, a large team, and just a growing business. And we're also very fortunate to be a part of that and to be joining in with them. We have been their largest CAM provider for 6 of the last 7 years. Just in February, we were excited to win the #1 top service delivery partner in the Americas. And that was a big distinction. So when you come over and work with us, you're working with one of the top partners that Autodesk has. We are a gold partner, and we're also an authorized training center with great scores for training in that group. We know that businesses are struggling with a lot of these things. We get calls in on a daily basis for support for companies that are looking for something that's better, so looking for something to help their teams to succeed, and also for the careers of those that are doing the programming. How can they get better at their craft and move to higher levels of capability? We see this in programming times. Some folks are still doing programming manually, or they might be suffering through a system that has a lot of picks and clicks to get anything done. Another thing is just more productivity out of these more complex parts where you've got multiple things going on, and maybe you have a revision cycle, or you have your customers making changes. And so we see a lot of companies that wait, and they're waiting until they can finally get the final part. And then that puts a lot of strain and stress to get that part done very quickly. Whereas we want to help customers and companies to handle that stress in a better way, to get a tackle on something earlier, and to know what the cycle times are going to be and know what it's going to take to get these products done in your shop. There's also increases in complexity. There's a lot of new technology out there. There's new machines that are coming out. This is a very great ground for innovation in the CNC market, where there's a lot of competition, and we can experience the great side of that by improving our processes and making things better. And but we have to take advantage of it. We have to look at the new features, the new capabilities that are coming out. So today we're going to be going over FeatureCAM and PartMaker. Primarily FeatureCAM in this discussion today, and it is one of our top CAM solutions, and it's used in really small shops, like a single person shop, all the way up to the biggest machine shops in the country that are using this as a solution. And they're using it because it's comprehensive. They're also using it because it's taking a lot of the easy stuff out of the way and getting it done for them, so they can focus in on the more difficult things and make sure those are precise and that they're not scrapping parts and having issues. But it's really comprehensive, all the way from milling, all the way up to complex turning and turn mill, and the Swiss type lathes. We've got wire EDM in here. And then it's also great for production and looking at how do I do the parts that I'm doing at the lowest cycle time possible. Then you throw in probing and the additional capabilities. We also sell FeatureCAM with Fusion, which is one of the products we talked about earlier, is the most popular CAM system on the market. So here's the traditional CAM workflow a lot of people are experiencing. I'm going to get a part or a drawing in. I'm going to create a setup. I'm going to select some type of operation. I'm going to select the boundaries for the tool to operate in. I'm going to select the type of toolpath that I want to be most efficient. I'm going to get my tools, my speeds and feeds, and my step overs. And then I'm going to simulate just to make sure everything's looking good. And then I've got my NC code generated. This is the typical path, and the good thing about this is a path that makes sure you're very accurate. You're going to go through each step and make sure all of these are in good shape. The hard thing about this process is there any changes, you've got to go back and redo all of these 6 steps. And this is the traditional workflow. What we're going to be showing you today is a feature-based programming workflow. This is going to be significantly faster. There are other programs that attempt to do this. I think that our solution does this the very fastest from the standpoint of identifying things out of the box. So when you get the product, you get FeatureCAM on day 1, it's going to be doing this right out of the box, and then you can also customize it. We often say that FeatureCAM becomes similar to your best programmer. So if you put in the programming techniques and styles that you like in your shop that have proven to be the most effective for your customers, then everyone can program that way and do things really fast. So I won't dwell on this too much. We're actually going to show this to you in the demonstration portion. What is a feature? You can look at here as a turning part and a milling part. It's something that has one or more associative operations. So you think about, hey, we've got to have the feature before it or the step before it, a step to do it, and multiple steps to do something in here. What FeatureCAM is going to do is it's going to automatically find all of these features for you and help you to get that first viable program done really quickly. And at that point, you can look at making it even better. The CAM platform at Autodesk is very successful. They have been making great strides in the market. If you look at it on the low end of the market or the higher volume end of the market, Fusion is the most popular CAM system that's out there today. If you look onto the high end of the market, for example, for like milling, is one of the most popular solutions. All of them are sharing the same algorithms and math systems across these platforms. So you're getting that built into FeatureCAM. So if you want to have the best code possible, a lot of that code is probably in here and it's been tested and run in multiple different programs. And you're getting the benefit of all of these capabilities coming together under one hood here. At this point, we're going to move into the technical demonstration. I'm going to hand it over to Andy Barney in just a second. Here are some of the parts. I was excited to see these and to look at the different variety that Andy's going to bring into the demonstrations today. It should be a pretty lively review of the capabilities. And so, Andy, I'm going to hand it over to you.
All right, thanks, Eric. Okay, so we're going to look at several things during this demonstration today, starting with, what is FeatureCAM really? Eric's done a pretty good job up front, kind of explaining feature-based technology is a way to speed up your programming times, and you'll see that evidenced when I show the parts. So this webinar is geared for people that may be curious about FeatureCAM or have another solution already within your shop, and you want to see if FeatureCAM can help reduce your programming times. And the answer to that is most certainly yes. Okay, so we're going to look at several parts. This one in particular for some feature recognition. I've got some, surface milling stuff and 5-axis turn mill with 5-axis stuff, B-axis machines, things like that. But in order to help you fully kind of grasp what FeatureCAM does out of the box, I'm going to work with something a little more simple. So I'm going to start here with just some, it's a DXF that I imported. It's actually a part I just grabbed one out of Fusion that I had and made a drawing out of it, exported it as a DXF and brought it over here. Obviously, there was a model with that, and using a solid model will always be faster in FeatureCAM, but I wanted some geometry on a part to kind of show you the workflow and how this works. Okay, so the first thing to look is there's a bunch of geometry, but let's talk about on the software itself. What is our workflow? So essentially we work with our stock, which I have represented right here. That's the first step if we were following through the workflow. Then we would either draw or import some geometry. There are CAD tools in FeatureCAM, of course, to do drawing. Just for purposes of speed, I went ahead and just imported a DXF. So a solid model is considered geometry. Surfaces are considered geometry. So if you need to draw them here, you can. If you want to draw them somewhere else, you can do that as well. The next thing we would do is make some curves or link pieces together that we want to machine. For example, I'm going to do the middle section here, and I'm going to make a pocket out of this. And so, okay, what be a pocket? Every CAM system can do that. But here's where things get separated with FeatureCAM. Okay, so the second that I have that curve, I can now use it. There are some other steps, surfacing and solid modeling if I needed it. You know, it's some basic stuff there where you can manipulate things, or, you know, fill in holes or make a solid model if you want. But we don't need to do that for this, so we're going to skip that area. Over here is a grayed out portion, and that is automatic feature recognition. If you see that little hover there, we'll see that on basically a bunch of these other parts where I do have solid models. So since I don't have a model, this is blank. So I'm going to go right into making a feature. So I want to use that curve that I had and make a pocket, right? So, okay, no big deal here, right? What's so unique about that? Well, I'm about to show you that. So I'm going to give it a depth of about 1/4 inch here. And I want you to notice something else on the interface. I'm going to show you this part view. And this is where you'll see things as we build them and create them. For example, there's my curve in the curves category. But under setup 1, which is right in the middle of the part, as soon as I hit finish on this, you're going to see I have a pocket. Okay. More importantly, though, what FeatureCAM has done is automated the rest of this. Okay, so I basically chained a curve after imported the geometry and did that. But FeatureCAM has created operations, so I have roughing and finish. And in fact, in roughing, I have 2 different tools, and it's based off what FeatureCAM sees as the radii in this feature. Okay, so it's trying to use a larger tool, and in this case, if we look over here on the right side, excuse me, under rough pass 1, that's a 1/2 inch end mill. Okay, and then it's picked automatically an 1/8 inch end mill. Okay, and that's because of the smaller radii that we see in this feature, and then it finishes it with that same 1/8 inch end mill. So not only did it pick the tools, but if we look and slide this over, we can see that it's calculated feeds and speeds as well. And so that's automated as well. So there's a feed and speed table within the software that has your surface feet per minute and inch per tooth values that you want to use. You can totally customize it. It's by material. In fact, if we look at this one, this part is aluminum. But if I look at the material list, I could make this out of dozens of different materials that come with feeds and speeds values pre-installed, and they are certainly able to be customized. So if you open up the feed and speed table, for example, on this aluminum, basically what FeatureCAM does to calculate that is it's looking at whatever type of machining I'm doing, profile or contour, slot work, facing, or plunge roughing, which is a surface milling strategy here. And then it's looking at the tool properties itself. Is it a high-speed steel tool with like a titanium nitride finish, or is it got a bright finish on it? Is it carbide? And all these numbers are all customizable to you. They are just suggestions to get you started, and you can tweak them to get them the way you want to do them. That's the one of the great things about FeatureCAM is the customizable aspect of it. Okay, so not only that, feed speeds, pick the tools, it's also calculated step overs and depth of cuts. All those things are already there. And if I were to go back to the workflow and look, after features is tool paths. So if I were to press that, we run a simulation, and I'm going to go ahead and hide the stock here. Sorry. We see the tool path in a wireframe. Here's our simulation modes. We can run this more in a 3D type of rendering. See the tool path, and I have something called tool colors. See where each tool picks. So if we look, here's the 1/2 inch end mill and what it did. And then if we watch that smaller 1/8 inch end mill, you see it's picking out that tighter area because the 1/2 inch tool wouldn't fit in there, right? And so you get the speed of the 1/2 inch tool removing material faster, and then it automatically just determined what to machine, right? So that's the awesome thing about the way FeatureCAM does this. Okay, so part of our steps, the NC code generation, well, that happens when you simulate. So if we look over here, I've simulated this tool path, and let me show you over here, down at the bottom over here, hopefully you can see the circle around my cursor. I now have NC code, and the NC code is based on whichever post processor I have actively loaded. And in this case, I've got a Haas 5-axis machine as an example, right? Obviously, this is not a 5-axis part, but you can still use a 5-axis post to post out 3-axis work. So I'm going to be showing some 5-axis stuff, so that's why I just grabbed one of those. Okay, so and then any changes you make, if I were to make a change, and go back to my part view and make a change. And maybe I want to change the Z increment on the half-inch tool. I'll say I go 1/8 inch at a time for some weird reason. That's what I want to do. I've made a change. The NC code is grayed out. I need to re-simulate it. It can be centerline simulation or 3D simulation. And as soon as you simulate, you've got updated code. Okay. All right. So I don't want to stick with this part. I want to get into some cooler looking parts now. But hopefully that helps you understand a little more about the automation that we're talking about. The other portion of the automation comes from what we call machining configurations or machining attributes. Attributes are the settings that were loaded in the document when I created it. Okay, I used the FeatureCAM defaults in this case. And so you can see there's drilling settings, there's pecking rules or settings, milling preferences. You notice I don't have cutter comp turned on or whatever. I have my step overs. This is where my depth of cut was set, 100% of the tool. That's really aggressive, especially if you're doing stainless or something harder, but totally customizable. The step overs here, you got different types of step overs you can do, and then values, percentages of the tool, how much material to leave for the finished pass, all the stuff you would do anytime you create a feature, essentially. So attributes are local to the active document that you're working in. When you create a new document in the beginning, you get to choose from any configurations that you have. And you see I have a few. FeatureCAM comes with a set of defaults that are there so that you can run the software, and you should learn about them, and then you would know how to make your own, what we would call configurations. So in this case, I have several files open in here. If you look across the top up here, we see up here, I got all these different files open. So the ones with the paper are attributes. Those are the attributes that are active in those documents, right? But then I've created some other ones in here, right? I've got what are called configurations. So I might have, could be machine specific, could be material specific, or a combination of the two like you see here. And I might have a different depth of cut rule, a different step over preference. I might have different peck amounts on my drilling, whatever those things are. You can just take a little bit of time and pre-configure those, because obviously if you're cutting plastic versus stainless versus aluminum or brass, those are different environments, right? And then it might even be that you have a Haas tool room mill that you cut, let's just pretend that's aluminum here, and then you got a mooring that you cut aluminum on. Those machines have different capabilities as well. So you can certainly create them all the way down to the finest detail you want. It doesn't take a lot of time. You don't have to run through every single setting. There's probably 10 to 12 that you would find you change all the time, like your step over percentages, your depth of cuts on that affects your and your depth of cut percentage, and then pecking, things like that, right? So you can do that. So the benefit is once you have those, you basically say, hey, I'm going to machine this. This is going to go onto the Morisiki machine. It's stainless 17.4. These are my preferences for that material for depth of cut, step over, and all the things I've mentioned. And you create that new document, and they now become the active attributes active in this document. So you can see that the step over is quite different than what we saw in the other document. So that's how that works. So that's how you can get things to be programmed the way you want in your shop. So Eric mentioned, make it as your best programmer, right? I like to call it, what are our shop standards? What do we know works? And let's do it. And that way anybody can do the programming part, and you get similar results because you're using the same type of settings. Okay, so let's look at something a little more advanced. Okay, so in this case, I have a solid model. You'll notice I also have some fixturing in here. The fixturing is here to represent the fact that we can simulate with that active, which would then allow us to collision check against it. So if we were going to run a tool or something into the fixture, we would see that. FeatureCAM does collision check your models and everything as well. So if you see areas where your machining. We'll see a couple collisions on this part when I program it. So that's important as well, right? Being able to see that here before you take it to the machine. So let's program this part. As you can see, there's quite a bit going on. There's a bunch of holes down there. There's looks like 4 out in the corners. There's a few areas where they stick up above that face. So cut around that, a pocket, if you were, an elliptical shape, this opening here. So we have a solid model now. So if I were to go back to the steps, you'll notice that I have the AFR button, the automatic feature recognition is active. I'm going to run this. This is one of the ways to use feature recognition. There are a couple, and I'm going to show them in this demonstration today. Okay, so the automatic feature recognition, it wants to know which solid is my part. I've got that one already picked. I have some preferences I can set in here. I'm not going to get into all that, but basically what are my kind of rules that I want it to follow? It's things like, do I want to face it or not? Things like that. So I'm going to run through it. I have one setup in here. If I had multiple setups, I would be able to program each setup from this initial AFR walkthrough, but I have just the one. So as I press next, you'll see within a couple seconds here, we're going to see that it's going to look at the model and it's going to extract features off of here. And you see all the different features that it recognized. Okay. And so if I were to want to keep those, you see there's my facing. I have a bunch of holes. In fact, if I scroll down here, you'll see I get down, there's 91 total holes. And then there's some milling features that are automatically recognized. So if I hit finish, I want to show you over here on the left side, over in the part view, here are all our features. Some of them are patterned like the holes to make it so this is not a 91 hole long list and all the other features. Plus it gives us a benefit of being able to change parameter and affects everything in the pattern, okay? But look over here on the right side, talk about automated. It picked tools, set feeds and speeds, depth of cuts, step overs, all the different things that we've talked about are already done. So if I were to go to simulate this, if we have any collisions, we will also get the benefit of that. So you can see, I can see my holder and my tools. I see the vise. We're not going to run into it on this part because we're not cutting that far down, but we may see a collision where a tool is too big or something along those lines, or a shank rubs or the holder hits. And here's the first collision that we see, okay? The nice thing about this is FeatureCAM, this arrow is representing where I am in the process. So I can just highlight that right there before I stop the simulation and go look at it. But let me show you what the problem is. So I'll go ahead and play it through again a little quicker. Okay, so we see it. It says the tool may have gouged or rapided in the material. So if I look, picked a center drill, and in this case, I can see what tool is right here. So center number 5. If we eject the simulation, I can see that hole is really close to the edge. So in this case, even though I picked a tool, it didn't consider this, but that's no problem. We see the collision, we can deal with it. The fact that it's in a pattern helps me out because I can just double click right on the tool here, go pick a smaller tool that I think will work, hit OK. Notice every single instance in that pattern updated. And not only that, we have a visual cue to show us this asterisk means that a manual override was made by the programmer. It's no longer allowed to be changed. Only a human interaction can change that. So no matter what I do to any of the settings and the attributes or whatever, that cannot be changed because I decided that's what's going to work, right? So now I've got no collision here. We're good to go. We'll have the drilling come up next. And so while we're watching this, I want you to think about how quickly we were able to get tool paths, a couple minor changes we might see, like that tool here. And then here's the other collision. I've got a holder that hits. So I need to extend that tool out in the tool properties or get a longer one and choose it or whatever. But basically a quick change and we're done. So 3D simulation does the collision checking, center line does not. So let's say that I made the change, but purposes of time, I'm just going to skip that. But we'll re-simulate and get the code. And I want to show you something else about this. FeatureCAM is also besides generating NC code, if we look at the details, it's also giving us an estimated machining time. So every single operation has rapids to get to and from the feature, an operation that's in the feature, the feed itself, the distance it cuts, all that. So, and that every tool change is counted, and it adds up, and it comes up with 27 minutes, 43.0 seconds. And then each operation shows you some information. Here's my step over based on an 85% facing step over. That's a default. You can change that. 33 seconds, right? Then the next operation, 6 minutes, 43.2 seconds, and then a minute 8, and so on. And so at the end of the day, you get this. And that comes in handy, really comes in handy if you're trying to quote jobs. You can run AFR on it, you know, get it reasonably how you might program it. You don't spend a bunch of time on it, and you can get a number out and quote it to your customer, okay? So super useful in that. So FeatureCAM makes all this stuff really easy, okay? There are other ways to do feature rec, and we'll see that on some of the other parts we're gonna do. So what I'm gonna do is I'm gonna skip over to turn mill now. So let's see how we can utilize turn mill in FeatureCAM as well, okay? I delete these two features right here. All right, so if I were to run AFR, which you'll notice there's a button up here, if I were to run AFR on this particular model in the turn mill orientation, then you would see a bunch of useful features and some that maybe I'm not going to machine it that way. So it's basically looking at the model and trying to come up with features that we can use here. Okay, so the first one it shows is a bore, the hole we're going to drill, so I'm not going to keep that. But it is trying to find things down the center and give you a boring tool path if that's what you want. I have a facing operation. I have some material. You see a gap between there and the stock. Yes, I want to face that. I've got some holes. Yep, there's 1, 2, 3. Okay, 3 holes, sorry. And then there's this feature that doesn't, it can mill what it can from that angle, but clearly we're not going to machine it that way. So I'll just deselect that and probably do that too. Now I could keep this one if I wanted to run the side of the tool here and come in along the Z-axis. I could keep that, but let me show you another way we could do that too. So that's a potential keeper, but in this case I'll drop it. And then of course the turning profile, which we see in red. Okay, so it got a bunch for me. So it's got the holes out of the way here, the turning, and you know, a few features out of the way. So AFR did pretty much everything the way I want. And I'm gonna just drag and drop over here and put turn after the face. They're sharing the same tool anyway. You can see the exact order of how things are gonna be machined. All right, so AFR didn't get it all. That's okay. AFR scans along the Z-axis. What it could get, it got. So the rest of this, use something called interactive feature recognition. And quite honestly, this is my preferred way of programming things, is run AFR, keep what you have, keep what you can. And then if anything you want to do differently, use IFR. I means interactive. So it's interactive feature recognition. So maybe I want to mill these flats next, and I want to do it with the end of the tool parallel or perpendicular to that. So basically cutting these walls away, right? So the way I would do that is go into my new feature wizard, and you'll see that I have turning features. So let's just kind of brush over those holes on the center line, grooves with a grooving tool, threading, facing, cutoffs with transfers, bar feeds, bar pulls, all that stuff. Turns and bores, grooves from a curve shape, threading along a path. So you see you got some of them grooves and threads. There's 2 different ways to make them. Part handling has the other things. It includes cutoff, but also has like slug transfers, reverse slug transfers, bar pulls, part support like tail stocks or steady rest, turning them on or off, ejects, things like that, right? So basically I want to do show you those, but what I really want in this case is a milling or live tooling scenario. So I have this turn mill, so I want milling type of features, and we see the same features we saw in the other milling document. So in this case, I want to do an open cut, which is a side. You kind of see that by the image here, and I'm just going to extract it. This is where I go into IFR. And so I'm going to tell it how to orient or clock the part for me. And I'm going to tell it I want the feature is not along the Z, so the tool's not coming this way. It's going to be on a B angle, right? And we're going to tilt it. So I'm going to say it's around the index axis of the part, and I'm going to tell it keep the end of the tool perpendicular to that face. Okay, and I can actually see a little temporary visual showing me my tool axis. The setup stays where it is, but this is just helping me see if I were milling this, Z axis would be pointing this way, right, in a regular mill. Okay, so that just gets my orientation. And then I can go in and say, hey, automatically find that. You see that it found this side feature, so I'll use that wall and I'll select it and choose finish. Now I could do that for each one of these, but the purpose of this demonstration is to show you how we automate things. So you see I'm interacting, I'm able to pull the feature off, but let's automate this a little further. Let's take that feature and let's pattern it. So we're going to pattern that side feature and we're going to go around our index axis, and there's 6 total at 60 degrees apart because I've already looked at it. I see the nice preview to make sure I got all that correct. So all the blue represents where those are going. I hit finish, and just like everywhere else, FeatureCAM's pick the tool, set the feeds and speeds, step overs, all that good stuff. Okay, so then we see the machining, and then we could do the same thing with our pockets. You know, go through here, do a pocket, extract with feature rec around the index axis. I'll pick the floor of that one. We'll start here. Okay, and then I'll press next, and I can have it automatically look for pockets. If it didn't get it, I could use the floor to pull out the pocket by using this method. Okay, add that in, and I'll add in a little wall here to set my top and bottom, and you see it found it that way. Or I could have, if I didn't get anything, I could pick all the side surfaces, which this little video will kind of show you what that would be. But obviously automatic found it, so that's going to be the fastest. So you have multiple ways to extract them if you don't get what you want with one of the methods. So I hit select and do the same thing. I'll go immediately. It's pick tools, feeds and speeds, step overs, depth of cuts, all that stuff. All I got to do is just keep cranking out my features. You know, pattern that, same thing as before, radial around, so you can see that you're spending less time on picking tools and depth of cuts and all that, and you're just focusing on simply making the features. Okay, so these ones are basically, you know, you could do that with most live tooling machines, right? But what about something like this where you're on an angle, right? Well, first we would probably need to face these off. So I'll do that. So I'm going to face that. So I'm going to do a new feature here, another milling. We want to do a facing with a facing tool, extract with feature recognition. It wants to know where. Now I'm going to click normal to that surface. You can see now the Z axis, so it tilts it. So you have to have a B axis head on your machine to do this, right? And then you choose that, and then you say, okay, that's what I want to machine. And then it's showing the thickness. I want to rough it because I'm going to have this whole corner to come away. So I want to rough and finish. And then if I want, I can pattern that, or I can just simply go over and make another one. It's totally up to you. You can just say, hey, that was fast enough. Let's go normal to this surface now. Got it. Next, use that surface. There's my thickness. It automatically detected that. Finish, pat, rough and finish, and we're good to go. Okay. And the easy part will be the holes, and we'll do those last. You see how I'm able to just quickly create them, and every time I do something, FeatureCAM's picking tools that should work. Feeds and speeds, step overs, depth of cuts. We might have to extend them out of the holder. We might change to a smaller center drill, or maybe we want to change a tool out, but at least it's getting you the bulk of the work done, right? And that's the whole point. So now I could do these open shapes over here, these little notches, those will be sides. I'll extract them, and I'm just going to say normal to this here, and choose automatic, and we'll see if it gets any. And in this case, it got 2 of them, so it got both of these, so it'll spin the part to orient to face the tool and cut those 2. And then I can come over here, I could pattern again if I wanted, or I can just repeat the process. But either way, the little amount of work that we're having to put into this, you know, is nothing in comparison to the way you would do this in other software, right? And you do pick it, and sure, you can probably pick things in similar ways in something you might be using, but you're not getting all this other stuff put in there for you, right? Okay, and then lastly, we'll just do the holes, and I'll do holes, and all the ones along the Z are already done. So when it says, do I want along the setup Z? I don't. I want around the index axis. And instead of picking each angle, I can just say automatically find all the holes that are not parallel to my Z axis. Okay, so that's going to be these, you know, all those. And in fact, when you see this, it actually recognizes these ones as counterbore. So we could have just done a counterbored hole and let it do the drilling and then counterbore that and end up with the same result. But I don't want that. So I'm going to keep just these ones right here and these ones here. So you can see I can manually pick them and hit finish. And then this, I'll get the last two. I just want to drill from one side, and you notice it was going for both sides and it had the counterbore. I just want to drill these out. So I'll do this again, and I'm going to say hole extract with feature rec. I'm not going to do automatic. I'm going to say, let's go normal to this. This is the orientation I want. And then I'll say, let's extract some holes out by just picking the cylinders themselves. Letting it just look at everything, and saying, let's focus on these two, and hit next and finish. And you see how quickly we are able to get to get program apart. So when you have a solid model, you can do it. Now this order on the right is exactly how it's going to machine. You're going to notice up here there's automatic ordering and there's manual ordering. So if you want, you can go reorganize the operations in the order you want. What it's basically doing now is kind of following this over here, but it's also, if I'm using the same tool, it's called minimize tool changes. If I'm using the same tool on one operation, let's group them together and do less tool changes. You can see the tool colors on, it shows everywhere a tool change happened. We see the different colors where it machined. Now, I'll show you one last thing here on this particular part, and that is machine simulation. So whether you have 3-axis or 5-axis or turn mill machines, we can machine simulate those. And in this case, I'm going to show you this particular part. I'm going to switch this over to like a Mazak Intergrex, show you what this would look like on that machine. You notice I have no results over here. Well, that machine doesn't have a B-axis, and I have features that require a tilting B-axis head to be able to do the face and the pocket and the holes, right? So I have to have that. So the software is smart enough to even be able to look at your post processor and say, hey, you don't have that, right? So I'll switch to one that has it, and I'll go with like this Morisiki one I have, and then you notice all my features come back. So let's look at a machine simulation. Start it up. I usually single step that when I do it. So this is a model where we've stripped everything out, but basically the main spindle, sub spindle, the lower turret, and the B-axis. We've taken the cabinet and the doors off, all that, just because we don't need to see all that. I do have another one in here that shows all that, a different machine, just so you can see the level of detail that we can have on a part. So here's a, oh, that's not a, oops, sorry, that's not a, it's the wrong one. I wanted the other one down here. There we go. I clicked the wrong one. There we go. Okay, so if your stuff doesn't align, you see, you can't use it, right? So we're going to stick with the NT for now, and then I'll show you the other ones on the other parts. Okay, so let's just kind of watch. So machine simulation will also collision check. Okay, so if we watch that, we can see it. If I have a collision, I see that the chuck has hit into the machine spindle, and we would need to address that, either pull the holder out or whatever we need to do. Okay, so there's a lot of capabilities in this software, and we haven't even talked about surface milling and 5-axis stuff, right? So if we look at something like this, this is a 5-axis part. We can also machine simulate this one. Let me create a few quick features. I'm not going to program this whole thing, but basically you just put a setup on an orientation you want to machine. But let's just start with, we'll just do this little pocket right here. So I'm going to say pocket, extract with feature rec, see what it finds. Okay, see if it finds anything along there, and it sure did, and I'll select it and hit finish. And then I could go on and go ahead and continue making other ones, the other features. But if I need something on an angle, then I just make a setup and I align it to my part geometry. And I basically say my Z direction is normal to that, kind of like what we saw before. I want X to maybe align, I don't know, from here to here. That would be our orientation of our X axis. And so you can see down here, that's our visual. And this is a new setup, and I can leave it down here. I can actually move it up by this other one. It doesn't matter. So I usually just leave it. But now I've got an active setup where I can now work on other features. And in this case, I might want to rough this out as a pocket, but you'll notice I got tapered walls. So I need to do some 5-axis swarf or something. So let's just do that real quick, just for we're running out of time, so I don't want to go too much further on these parts, but just showing you the capabilities. And I'll say, let's use this as my shape. And then I'll set one of these walls in here to set top and bottom, even though that's tapered. Then I get a pocket. Vertical walls, set the top and bottom, have that. And then the rest of this, I can here, hide this feature. I can take the rest of this right here. Sorry, I'll get rid of that top one here in a second. So we have different selection modes where you can click all at once, which you saw how that can be kind of tedious, or we can do a drag select like I'm doing here and just paint over it and say, okay, I want a feature. This will be a 5-axis swarf. So let's talk about surface milling for a minute. There's tons of strategies in here. We're gonna run out of time before I can even really talk about them, but we have all kinds, roughing strategies, Z-level and parallel. We got tons of finishing strategies, but specialized strategies like a swarf. It can be a 3 or 5-axis. Do that, stuff like that, and we'll take a look, and you'll see it's picked a tool, and I'm going to just basically tell it to go one direction. And if we just preview this, let me go ahead and preview this toolpath. You'll see the, oops, let me refresh my graphics. Hang on, let me do that real quick. So it's coming out a little blocky. I think that's the webinar is taking up some of my graphics capabilities. So let's preview this again. See if that comes out round like it's supposed to. There we go. And it looks like it's a little bit too big for that, so we can switch it to it. But you see the 5-axis motion in there, just doing that. So I'll go ahead and swap that tool out, put in like a 1/4" end mill, grab something like this one. And these tools all came with the software. They're there for you to use to build your tool crib. But we can see all the different stuff. And let's just kind of take a look at this on the machine real quick. I think I have block stock. Oh no, I already have. I mean, so here's the Haas with 5-axis. You can see the doors, the cabinets. You can hide all those or have them stripped out. I can just basically get them out of my way each time or whatever. Notice which way the part is tilted. So it's tilted the trunnion towards me, the part away from the operator, and it's doing it. Let me show you how we can actually make a quick change and say, hey, let's do an alternate positioning, and watch what the difference is on this. Now, when I start this, it's going to kick the trunnion away, just a couple check boxes, and it kicks the trunnion away and the part towards me. So maybe I want to be able to see the work there better, and I can see the machining that's being done and all the motion and everything. And it's really super simple. Okay, so I've showed you basically all the big ticket items on things, other than showing you all the surface mill strategies and things like that, right? So I have a few more minutes, so I'll just show you a couple of things with the roughing right here. So the blue is my stock. I'm going to hide that. I'm going to actually just throw on some surface milling just so you get a feel for that. And I'll even finish it as well. I'll just run through this whole thing. So Basically, I'm going to do a Z level or parallel rough. I'll start with that, show you what I would typically do. I'm going to machine it, but I'm going to introduce something called step cutting, where it'll take a slice at a given depth and then it will step back up and only take slices or machine more at this particular thing and increase the feed rate while I do it. So what happens is we get something like this. So let me show you the first slice on this. Okay, whoops, I'm on 3D. Sorry about that. Let's do 3D so you can see that. Okay, so I've got different simulation controls to kind of show us how to do it. So you see right here, it's going to take looks like a pretty decent size cut. Okay, so it's cutting all that, and the step cutting I turned on was to have it step back up after it's done with the initial, and you'll see it do all these steps back up the part. It's actually increasing the feed rate by 400% of the original, or up to. It's actually looking at it and giving you different feed rates per slice based on tool load. But you see how it's able to go ahead and come back and knock the rest of this stuff off of here and give you a nice part pretty close to being ready for finished tool pass. Let me go ahead and swap this out. I'll show you, I'll change the process right here and throw in a parallel rough just to show you that. And I'm going to just go ahead and throw in a couple settings. I want to give it a Z increment of like a 1/4 inch. It's going to be a ball mill on this. I'm going to have it skip the final pass right here for now. And then one setting I want to do is here, something you don't need to worry about now, but we cover that in training if you were to be training with us. So a couple quick little changes is all I did. It picked the tool, okay? You see that I get this result, which is nowhere near as pretty as the Z level was, right? But I can go back into here and what I want to do is introduce what's called a final pass, which if you notice, I turned that on purpose just to show you what this would do without it. Defaults to this. So then we get what we get is that initial chunky look. And then let me try to catch it here just to show you capabilities, right? So it gives you that chunky look, and then look, it ran right over the top of it again and knocked those scallops off. And of course, I got a pretty aggressive step over. And so we can shrink that to say 20% of the tool, get a better finish, right? Obviously we're roughing. And I can even do things like adding in perpendicular remachining passes. So we'll get the initial chunky look, we'll get the final pass. Okay, so after it does all this, where we got the scallops and stuff, it runs the final pass over. There we go. And then after this is done, it's going to come over it perpendicular to my machining that we did again one more time. You can see it's cleaning up other portions of this. And I had a slope angle of 0, which means basically machine everything. But it can actually optimize this and have the original parallel only do the areas above my slope limit, and then the steeper areas just be done with this perpendicular. And the way that's done is just another quick little checkbox, optimize it, and my limit is 30 degrees. So anything above 30 degrees, do the parallel pass. Anything below, just do the regular first, or the perpendicular pass would be above that. And just watch the difference in the machining. And then if you're paying attention each time, if you check your estimated machining time, so you see how only that, it didn't go over the whole thing with the perpendicular, only in these areas. But you can always pay attention as you're making changes. What is this doing to my tool path, right? So we got 15 minutes and 22 with this method. What if I go back to my original Z level that I had kind of worked out, and what do we got here? We run it, and I can go back to the details as soon as it's done. That one's even better looking, and it was a little faster, right? So it's important that you know you can do that. So with the time we have left, I think that's all I have time for. Clearly, FeatureCAM can do everything. So, you know, it does, you know, milling, turn mill. Swiss is basic. Part maker would be better for that. We do vertical mill turn machines, wire EDM, multiple fixture documents where you can add more than one part on a table, multiple vices, or if you have a 4-axis tombstone machine or whatever, you can do that. And of course, this machine design is more for us to deal with those machine simulation files that I showed you. So appreciate your time. Hopefully that gives you a high-level overview. And if you have any questions at the end, I'm happy to answer them. But for now, let me go ahead and turn it back over to Eric.
All right, thanks, Andy. Great job going through all the parts. It's so fun to watch it come together, bringing up the different parts and pieces and the different strategies and looking at them. And having used several of these different solutions, it's great to see how FeatureCAM kind of makes it easy for folks. So thank you for running through those parts. I also wanted to go over just our FeatureCAM training classes. We do quite a bit of all 4 of these. And we have an essentials to intermediate training. It's a 3-day course for new users, and it runs on a very consistent schedule. It's the 3rd week of every month. If we have too many students, we'll bump it up to have 2, 3, 4 extra courses, whatever's needed to handle the groups in those scenarios. You can see it's in our online calendar. You can go and sign up. It's April 19th, May 17th, and then June 21st are the next iterations and times that this would run. We also do quite a bit of advanced training, and we would like to often get very customized with you on advanced training into certain areas and the things that you're really doing in your shop that you need help with. It could be surfacing, it could be 5-axis, it could be turn mill advanced, a bunch of different topics. Definitely, if you want to call us or talk to us about it, we would help you put something together. On-site training is also something we're doing quite a bit of, and you could get a hold of us with the training email, training@nextgencam.com, review requirements with one of the training experts, or even just call your account manager and make a plan together. We also do best practices. These run the 2nd Friday of every month. You could sign up for these on the NextGen website to attend these regularly, and then we also give access for you to see the past history of those. We also have added a bunch of additional classes. If you aren't aware, we expanded earlier this year by adding another partner, actually 2 additional partners. So we're also covering Inventor and Vault and all the training across the whole Autodesk manufacturing portfolio. The calendar is a nice place to go, though. It is CAM training by CNC professionals. I think that's where we really distinguish and shine, is that all of our trainers have both run CNC machines, have used multiple softwares in industry. And so when you're working with them, you're working with a true consultant. It's not someone who's just going to be, hey, I'm going to teach you pick and click training. I'm actually going to make your shop better. I'm going to run your machines faster. I'm going to help you to do programming a different way than maybe you've done it in the past. You can see all these other CAM products from Autodesk. We're also running sessions with them. And it's really easy to get started with FeatureCAM. It's probably one of the easier products on the market that you can be up and running and see a significant, tangible benefit. Whereas the way I was doing it before, I'm actually doing it faster than the way I was doing it before, rather quickly. Often we want to look at who are the programmers on your team. Which of the CNC machines are getting the most usage on short run projects and getting a lot of programming. We want to set up or configure your post processors to that exact machine, since every machine could be a little bit different. Attend training, and then we will support you and help you to get those initial few projects up and running. You can then leverage our support team as you continue to expand your knowledge and attend the monthly best practices so you can keep brushing up on new areas of the product and new skills you can pick up. And typically we'd like to do, sometime between the 3 and 9 month mark, a health check. So get a tech on the call and see what you're struggling with once you're actually operational. There could also be things like add-ins. There are a huge library of add-ins in FeatureCAM where we can help you configure an extra capability or something that's not there right out of the box. As I mentioned earlier, we've been expanding into these different solutions. These are things that have been really exciting and hot topics for people. We've had a lot of folks contacting us about DNC, distributed NC, and managing that without their shop floor and with the Simco product lineup. Another one is Upchain, which is a data management and lifecycle management tool to improve collaboration for folks. We have another webinar on that later this month if you'd like to learn about it. And then Vault for Make. Vault is the desktop server-based data management system that Autodesk has. It's a very popular, very sturdy program that's running extremely large organizations. And they've added something called Vault for Make, which is extending that capability to the shop floor. So you may have a design file and you want to track also the programming with it in FeatureCAM and PowerMill. It has an integration into FeatureCAM and PowerMill. And then you also want to track your NC code and make sure that everything that you do in the shop is tracked and you don't lose something. It's really quite amazing how many folks out there that do all this work to get a perfect part cut, and then they lose track of the final NC code that cut that part. And you really want to do that. That's where the Vault for Make solution is going to help you improve in that space. Last but not least, there is a large Fusion promo going on. So if you're looking for just Fusion by itself, that's obviously one of the more popular CAM programs out on the market. You can see on our site, we've got 25% off of Fusion 360, all the products and all the services. It is a tremendous spring sale. And if you want to take advantage of that, definitely just hit our website here, call us with the numbers that are on the site, or get a hold of us in a number of different ways, and we can help you with that.